This video is going to be on how to find inverses algebraically. Alright, so first we're going to make sure that we know what inverses are. So inverse operations, you might have heard the term, you might not, but you definitely recognize what some of the operations are. So we have three main inverse operations that you guys have worked with before. The first is addition and subtraction. The second is multiplication and division. And then the third is squaring a number and square rooting. And you could also say cube and cube rooting, raising an exponent to the fourth, or raising something to the fourth power, and then fourth rooting, etc., etc. So those are the inverse operations you guys have worked with before. So sometimes people think of inverses as opposites of each other, which is true but not super accurate mathematically. So what we're going to say for inverses is that they are operations that undo each other. So that's how we want to remember inverses. They are operations that undo each other. All right, so when we look at inverse functions, we have a specific notation that we use so that you can tell what the original function is, and then you can tell what its inverse is. So if the original function is written as y equals, then the inverse function would be written as y inverse equals. So it looks like it's an exponent of -1, but when we say it out loud, we say inverse. If your original function is f of x equals, then the inverse function would be f inverse of x equals. If your original function is g of x equals, then your inverse function would be g inverse of x equals. So that's how we show which functions are connected with which inverse, is you just use the same notation, you just stick a little, kind of like a -1 exponent on it, and then call it the inverse. All right, so to think this through, we just want to make sure that we can take this idea of inverse operations and apply it to a situation where we're talking about an algebraic equation. So if we use the example of the equation y equals 2x minus 3, and we write down in words what's happening to that x value, the first thing that happens to the x value is you multiply it by 2. The second thing that happens to that is once you've multiplied your x value by 2, you subtract 3 from the result. So if we're going to find the inverse of that, we're going to do those operations and we're going to undo them, and we're going to go backwards. So we're going to take whatever the result is from this. So this is the original. And for us to undo those operations, then if the last thing that happened was they subtracted 3, then the first thing we would do is we would add 3. After that, they had multiplied by 2, so to undo that operation, we're going to divide by 2. So if you were to think of a number, let's say we're thinking of the number 5, and you multiply 5 by 2, you get 10, and then you subtract 3, you get 7, right? So if we take that number, we're starting with the number 7, and we add 3 to that, we get 10, and then we divide by 2, we get back to 5. So inverse operations are saying you can do a group of operations, start with a number, do a group of operations, get to a final number. The inverse of that would say start with that final number, we're going to undo all those operations, it's going to get us back to our original. That's what inverses do. So if we think about this in the sense of an equation, if you take an x and you multiply it by 2, you get 2x. If you subtract 3 after that, that would be 2x minus 3. If we do the inverse, then we're going to say take the x value, so we have a new x value this time. We're starting with what we ended with in the previous equation. So take the x, add 3 to it, and then take that and divide it by 2. So if the original function was y equals 2x minus 3, then the inverse function here would be x plus 3 divided by 2. Now what I've found is that if you look at this in words, you can kind of see it makes sense. But if you compare the equations, you might be able to see how they're inverses, but it doesn't make as much sense as the words do. So we want to make sure that when we're learning inverses for the first time, we think about the words. We think about what we're actually doing to the number, and then we reverse that. We undo that. All right? So here's how we're going to do this part by hand without doing the words in between. So we're going to say how to find an inverse algebraically. We have 3 steps. The first step is to switch the x and the y value. So when we came down here, if we said that the x value we're starting with up here, we're plugging 5 in for x up here, then that means that 7, that's the y value we get down here. You plug 5 into the function, you get 7 as a result. So the first thing we do is we switch it. We say, all right, your end result of the original function is going to be the beginning number of your inverse. So you switch the x and y. Second, you're going to solve for y. So you're going to have all these operations that are being done to y. As you're solving for y, as you're trying to get y alone, you're going to undo each one of those operations. You're going to do the inverse of each operation. And that's what gets you down to the new y. You get the y alone. And that would be your original number. It'll make more sense once we do it. So next step, solve for y. And this is the part of the process where you are actually undoing each operation. And then your third step is to take your final answer and write it in the correct notation. All right, so we're going to do a couple of these to practice and just make sure that we truly understand what inverse operations are and that we can actually write them algebraically. So 2 examples. The instructions when you do an example, or when you do any problem, not just examples, but the instructions would say something like find the inverse. Or they might say find the inverse function, or take the function and find the inverse. They'll say something with the word inverse in it. So first, we're going to consider the function f of x equals 2x minus 1 divided by 3. So if we think about the original in words, and again, I'm writing out the words not because you do have to do this every single time. I'm writing out the words because we're learning it right now, and I want to make sure that it kind of makes sense what we're doing. So if you think about the x value, the first thing that happens to it is you multiply the x value by 2. Once you have taken that x value and multiplied it by 2, then you subtract 1. After you've taken the x value, multiplied it by 2, and subtracted 1, then you divide by 3. So the inverse is going to do the opposite of those things in a reverse order. So we're going to take whatever number we get at the very end, and to go backwards, to undo all those operations, if we divided by 3 as our last step, then our first step here is going to be to multiply by 3. After we multiply by 3, we're going to undo the subtract 1, so we're going to add 1. And then our last step is we have to undo the multiply by 2, so we have to divide by 2. All right, so if we write out all these steps algebraically, first step is to take your x value and multiply it by 2. Second step was to take that answer and subtract 1 from it. And then the last step was to take that previous answer and divide it by 3. So that's our original function, y equals that. Our inverse function is going to say, take the result from this one, call it x, take that, multiply it by 3. 3 times x. Take this answer and add 1 to it, 3x plus 1. Take this answer right here and divide it by 2. And then we're going to write this, we're going to say this is the inverse function. All right? So now we're going to go ahead and do this without the word so we can see how it would work if you just use plain math when you do the problem. So I'm going to go ahead and rewrite this with a y, so it doesn't have the f of x, because that can be kind of confusing if you trade x and f of x. So first step, if we remember, the first step is to switch the x and y. The second step is to solve for y. All right, so step 1, switch the x and the y. So I'm going to say x equals 2y minus 1 divided by 3. There's step 1. Step 2 is to solve for y. So when we solve for y, we are undoing each operation. So the first operation that I can undo is that divide by 3. So I'm going to go ahead and multiply by 3 on each side. So that gives me 3x equals 2y minus 1. The next operation that I can undo to get the y alone is I can add 1 to the other side. So 3x plus 1 equals 2y. The next operation I can undo to get the y alone is divide by 2. So at this point, we have y equals 3x plus 1 all divided by 2. So if you recall, the very last step was to write your answer in the correct notation. So if you compare this with the original problem said f of x equals, so we need to write our problem as f inverse of x equals, and then we have 3x plus 1 divided by 2. So when you do these problems, this is the way you can think of it if you need to use your common sense to kind of make sense of the problem, but mathematically this is all you have to show. All right, we're going to go ahead and do another example. So for this one, the problem is y equals x plus 2 squared minus 3. So for the original problem, they took the x value and first they added 2. Once they got the result from that, they took this number, whatever it happened to be, and they squared it. Once they got this result, they subtracted 3 from it. So we are going to go ahead and reverse that process. So first we are going to undo the subtract 3 by adding 3. Next we're going to undo the squaring something by square rooting it. And then last we are going to undo the add 2 by subtracting 2. So if we consider the original problem, you start off with x and you add 2. Then you take that number right there and you square it. And then you take this answer right here and you subtract 3. That's the original problem. For our inverse, we're going to take a value and add 3 to it. Once we get that answer, we're going to square root that answer. Once we get a result for that, we're going to subtract 2. So now we're going to go ahead and do the math to find the inverse by hand, just using algebra, not using words. So here's our original function. We're going to go ahead and trade the x and the y. So x equals y plus 2 squared minus 3. The first thing we're going to do to get y alone is we're going to add the 3 to the other side. So x plus 3 equals y plus 2 squared. The next step to get the y alone is we need to get rid of that exponent, so I'm going to go ahead and square root it. So the square root, go ahead and skip a line, the square root of x plus 3 equals y plus 2. And then our last step to get the y alone would be to subtract the 2. So we have the square root of x plus 3 with a minus 2 equals y. And then last, we just have to make sure that our notation matches. So the original problem said y equals, so that means that our inverse is going to say y inverse equals.